Welcome! Today we'll learn about reciprocal equations, also known as palindromic equations. A reciprocal equation is a special type of polynomial equation that has an interesting property. If x is a solution to the equation, then 1 over x is also a solution. Let's look at a simple example. Consider the equation x squared plus 1 equals 0. This is not a reciprocal equation, because if we replace x with 1 over x, we get a different equation. Now, let's look at a true reciprocal equation. Consider x squared plus 1 over x squared equals 2. When we replace x with 1 over x, watch what happens. Let's solve this reciprocal equation. First, let's let y equal x squared plus 1 over x squared. Then y equals 2. We can rearrange this to x to the fourth minus 2x squared plus 1 equals 0. This is a quadratic equation in terms of x squared. Let's solve this quadratic equation. The equation factors to u minus 1 squared equals 0. Therefore, u equals 1, which means x squared equals 1. So x equals plus or minus 1. And notice, these solutions are reciprocals of each other. Let's verify these solutions. When we plug in x equals 1 or negative 1 into our original equation, x squared plus 1 over x squared equals 2, we get 1 plus 1 equals 2, which is true. To summarize, a reciprocal equation is a polynomial equation that remains unchanged when x is replaced with 1 over x. When solving these equations, we can often simplify them by making a substitution that leads to a quadratic equation. The solutions often come in reciprocal pairs, meaning if x is a solution, 1 over x is also a solution. Let's solve the quadratic equation 5x squared minus 30x equals 0 by factorization. The first step is to identify the common factor between all terms. Looking at 5x squared and negative 30x, we can see that 5x is common to both terms. Let's factor out 5x. Now, we can use the zero product property. This property states that if the product of factors equals 0, then at least one of the factors must be 0. So either 5x equals 0 or x minus 6 equals 0. Let's solve each equation separately. For 5x equals 0, we divide both sides by 5 to get x equals 0. For x minus 6 equals 0, we add 6 to both sides to get x equals 6. Let's verify our solutions by graphing the quadratic function. Here's our coordinate system. The blue curve represents y equals 5x squared minus 30x. Notice how the curve intersects the x-axis at x equals 0 and x equals 6, confirming our solutions. Therefore, the solutions to the equation 5x squared minus 30x equals 0 are x equals 0 and x equals 6. These x values are where our quadratic function crosses the x-axis. In summary, we solve this quadratic equation by first factoring out the common factor 5x, then using the zero product property, and finally solving the resulting linear equations. The graph confirms our algebraic solution. Welcome! Today we'll solve the quadratic equation 4x squared minus 3x equals 14 using the quadratic formula. First, we need to get the equation into standard form, which is ax squared plus bx plus c equals 0. Let's subtract 14 from both sides to get all terms on the left. Now, we can identify our coefficients. A equals 4, b equals negative 3, and c equals negative 14. Let's recall the quadratic formula. X equals negative b plus, or minus the square root of b squared minus 4ac, all over 2a. Now, let's substitute our values. We'll put in negative 3 for b, 4 for a, and negative 14 for c. Let's simplify step by step. First, let's simplify negative 3 to positive 3. Next, let's simplify what's under the square root. Negative 3 squared is 9, and 4 times negative 14 is negative 224. Adding 9 and 224 gives us 233 under the square root. The square root of 233 is approximately 15.26. This gives us two solutions. For the plus sign, we get 3 plus 15.26 over 8, which is approximately 2.28. For the minus sign, we get 3 minus 15.26 over 8, which is approximately negative 1.53. Let's visualize these solutions on a graph. Here's our quadratic function. The x-intercepts at 2.28 and negative 1.53 are our solutions. Therefore, the solutions to the equation 4x squared minus 3x equals 14 are x equals 2.28 and x equals negative 1.53. Let's find the discriminant of the quadratic equation 9x squared plus 25 equals 30x. First, we need to rewrite the equation in standard form. The standard form of a quadratic equation is ax squared plus bx plus c equals 0. To get our equation in this form, let's subtract 30x from both sides. Now, we can identify our coefficients. A equals 9, b equals negative 30, and c equals 25. The discriminant, which we denote with the Greek letter delta, is given by the formula b squared minus 4ac. This formula helps us determine how many real solutions our quadratic equation has. Let's substitute our values into the discriminant formula. We have negative 30 squared, minus 4 times 9 times 25. Now let's solve this step by step. First, negative 30 squared is 900. 4 times 9 times 25 is 900. So 900 minus 900 equals 0. Since our discriminant equals 0, this tells us that our quadratic equation has exactly one real solution. This makes sense because when we graph this equation, the parabola will touch the x-axis at exactly 1 point. In summary, we found that the discriminant of the quadratic equation 9x squared plus 25 equals 30x is 0, which means this equation has exactly one real solution. Welcome. Today we'll find the sum and product of the roots of a quadratic equation. Let's solve this step by step. Step 1. Let's identify the coefficients. In the standard form of a quadratic equation, x squared plus bx plus c equals 0, we can identify that a equals 3, b equals negative 5, and c equals 7. Step 2. Let's recall the formulas for sum and product of roots. For the sum of roots, x1 plus x2 equals negative b over a. For the product of roots, x1 times x2 equals c over a. Step 3. Let's calculate the sum of roots. Substituting b equals negative 5 and a equals 3, we get negative of negative 5 over 3, which simplifies to 5/3. Step 4. Now, let's calculate the product of roots. Substituting c equals 7 and a equals 3, we get 7/3. Therefore, the sum of the roots is 5/3, and the product of the roots is 7/3. To summarize, we found these values by 1. Identifying the coefficients, 2. Using the sum and product formulas, 3. Substituting the values, and 4. Simplifying to get our final answer. Let's solve this complex number problem step by step. We need to evaluate omega plus omega to the 38th power minus 5, where omega is a complex cube root of unity. Step 1. Understanding the properties of omega. Since omega is a complex cube root of unity, it satisfies the equation omega cubed equals 1. We also know that 1 plus omega squared equals 0. Step 2. Let's simplify omega to the 38th power. We can divide 38 by 3 to simplify this. 38 equals 3 times 12 plus 2. Therefore, omega to the 38th equals omega to the 3 times 12 plus 2, which equals omega cubed to the 12th power times omega squared. Since omega cubed equals 1, this simplifies to 1 to the 12th times omega squared, which is just omega squared. Step 3. Now we can substitute omega squared back into our original expression. Our expression becomes omega plus omega squared minus 5. Step 4. Using the property we learned earlier, 1 plus omega squared equals 0, we can rearrange this to show that omega plus omega squared equals negative 1. Step 5. Now we can substitute negative 1 for omega plus omega squared in our expression. This gives us negative 1 minus 5. Step 6. Finally, we can evaluate negative 1 minus 5. The answer is negative 6. Let's review the key steps we used to solve this problem. We used the properties of complex cube roots of unity, simplified the high power of omega using modular arithmetic, and used the sum property of omega to reach our final answer of negative 6. Welcome to our lesson on inverse variation. Let's learn what it means when two quantities vary inversely with each other. Inverse variation is a relationship between two variables where as one variable increases, the other decreases, and vice versa. Mathematically, if y varies inversely as x, we write it as y equals k divided by x, where k is the constant of variation. Let's visualize this relationship with a graph. As you can see, when x increases, y decreases, forming a curve called a hyperbola. Notice how the product of x and y always equals the same constant k. Let's look at a real-world example. Suppose a car needs to travel 120 miles. The relationship between the car's speed and the time taken follows inverse variation. Let's calculate some values. If the car travels at 60 miles per hour, it takes 2 hours. At 40 miles per hour, it takes 3 hours. And at 30 miles per hour, it takes 4 hours. Notice that in each case, when we multiply the speed by the time, we get 120, our constant of variation. This confirms that speed and time vary inversely with each other when traveling a fixed distance. To summarize, in inverse variation, as one quantity increases, the other decreases, while their product remains constant. The formula y equals k divided by x helps us calculate exact values, where k is the constant of variation. Let's solve this proportionality problem step by step. We need to find the value of k when it is proportional to 1 over b squared, and we know that it equals 3 when b equals 4. Step 1. Let's express the proportional relationship as an equation. When we see the proportional symbol, we can convert it to an equation by introducing the constant of proportionality k. So, it equals k divided by b squared. Step 2. Now let's substitute the given values. We know that it equals 3 when b equals 4. So, let's substitute at equals 3 and b equals 4 into our equation. Step 3. Let's solve for k. First, let's simplify 4 squared in the denominator. This gives us 3 equals k over 16. Now, multiply both sides by 16 to isolate k. This gives us k equals 3 times 16, which equals 48. Let's verify our answer by checking if it works in our original equation. If we substitute k equals 48 and b equals 4 back into our original equation, we should get it equals 3. In summary, when we have a proportional relationship, we can find the constant of proportionality by substituting known values and solving the resulting equation. In this case, we found that k equals 48. Welcome! Today we'll learn how to find the mean proportional between two numbers, 20 and 45. Step 1. Let's understand what a mean proportional is. The mean proportional between two numbers a and b is a number x such that the ratio of a to x equals the ratio of x to b. Step 2. We can rewrite this equation by cross multiplication. When we cross multiply, we get x squared equals a times b. Step 3. To solve for x, we take the square root of both sides. This gives us our formula x equals the square root of a times b. Step 4. Now let's substitute our values. We have it equals 20 and b equals 45. Step 5. Let's calculate this. First, multiply inside the square root. 20 times 45 equals 900. Then take the square root of 900, which equals 30. Let's verify our answer. If 30 is the mean proportional, then 20 over 30 should equal 30 over 45. Indeed, both ratios equal 2/3, confirming our answer is correct. Therefore, the mean proportional between 20 and 45 is 30.